Okay, so we're going to do this video here is going to be calculating probabilities for z-scores for the normal distribution. So in other words, it's not just any z-score, but just those for the normal distribution. And I have here drawn the standard normal. And please remember, the mean of the standard normal is 0, and it always has a standard deviation of 1. So basically, z equals 0 is right here in the center. And notice the mean and the median are exactly the same. And by the way, if you didn't watch the first video, please watch that, or at the very least, go back and read the first few pages of the notes. There's some really important information there. Between -1 and +1 is 68%. Between -2 and +2 is 95%. Between -3 and +3 is 99.7% of the data. All right, and remember that is known as the empirical rule. And the empirical rule applies only to normal curves, but it applies to all normal curves. Please remember, there's an infinite number of means and standard deviations for normal curves, but the standard normal, which is the one we use a z for, the standard only has a mean of 0 and a standard deviation of 1. So the standard normal is always mean of 0, standard deviation of 1. Now, one thing to remember, and this has to be a little bit caution, the empirical rule is not a percentile rank. You go, wait a second, those are percentiles. And I'm going, yeah, they are percentiles, or they're percents, they're not percentiles. 68% is between here, 95 is between here, and 99.7 is between here. But a percentile rank is when you put everything from least to greatest in order, and that is a percentile rank. I am at the 95th percentile in my class. That means 95% of the people are below me. Or consider this. What does it mean if you scored at the 78th percentile of students taking the SAT test? It means that 78% of the students scored lower than you did. So the percentile is the 78th percentile. It also means 22% scored better than you did. This is not a percentile rank because it went from top down. Remember, percentile ranks always go from the bottom up. So let's use the calculator and let's calculate some percentile ranks for some z-scores. And basically, we're going to just calculate these z-score percentile ranks. All right? So we want to calculate the percentile rank for a z less than -3. Well, I'm going to go ahead and draw my picture because this is what it says. Draw the graph, label the mean, label the upper and lower. And this is really important. My students that do this do very well on this. Those that don't tend not to do so well. So I really want you to go about, do this as well every single time. So here we go. We know the mean is 0. All right. And we want a z-score of -3. Well, I know it's negative, so it has to be below 0. And I'm not going to worry too much about it, but I want -3. And since it's pointed this way, I'm shading in that direction. I always shade in the direction of my arrow. So we have -3 here. Well, this is a normal, and by the way, we're going to use on a calculator, we're going to use this, and you need to write this down every single time, norm CDF. All right, well, what was my lower? Well, this goes all the way to -infinity. Well, we write -999 a bunch of times. So here we go. And then the next one, my upper. Well, what is the upper part of the shaded part? Because this went to -infinity and it upper to -3. The next thing is a mean of 0. And what's the standard deviation of the standard normal? 1. All right. So that would be me showing my work for this. And then we're going to go to the calculator. And we're going to go second vars. Excuse me. Second vars, normal CDF. Please make sure you choose the CDF. We will never, ever use the PDF. We will never use the PDF in this class. We'll only use the CDF. The second vars, normal, CDF. The lower bound, -99999, filled it up. The upper bound, we said was -3. Make sure you use the little negative button down here at the bottom. Use that for your negative, so -3. The mean is 0, standard deviation of 1, because it's a standard normal. It's not just any normal, it happens to be the standard normal. And we end up getting 0.0013. And we always want to take these out to 4 decimal places. So equals 0.0013. That's my answer. I'm done. Box it in so I can find it easily. Okay, so let's do the next one. The next one is z less than -2. Well, once again, my mean is 0. We're on the negative side, so we're below 0. So I'm just going to put this at -2. I'm shading this way. This is negative infinity. And once again, we have a norm CDF. And if I go to my calculator, it'll tell me what I need to put. Second vars, norm, make sure you have the CDF. It asks for my lower. Oh yeah, that's -99999. -999 ... Then my upper bound, well, what is the upper part I shaded? The upper part that I shaded, and I know that's kind of hard to see, is supposed to be a -2. Mean is 0, standard deviation of 1. So let me change this to a -2. Oops, -99999. -2, 0, 1. And I end up getting 0.02275. And whether you round or you truncate doesn't matter to me. So this one equals 0.0227. Box it in. Now we want to do the same thing for -1. So we're going to draw our picture. Negative infinity, normal curve. And by the way, I don't draw these perfect and you don't need to either. So -1, right there. We know it's a normal. Norm CDF. My lower, well, we went to negative infinity, so -9 ... My upper bound is -1. My mean is 0. My standard deviation is 1. Second vars, normal CDF, -1. Oops, -1, 0, 1. And we end up getting 0.1586. All right, probability that it's less than 0. And I know I wrote -0, which is right, less than 0. Well, if I looked at this, what do you think that's going to be? Well, that's kind of cutting in half. So I better have half of 1 is going to be 50%. So I'm going to bet this is 50%. Let's go ahead and check it out. All right. So 0, we're going all the way to here, negative infinity. Once again, it's a norm CDF. And we're going from -99999 to 0. Mean happens to be 0. And our standard deviation is 1. Because that's exactly what we have to put in the calculator. Second vars, norm, CDF, -99999. The upper bound, where we stop shading, is 0. Our mean is 0. And our standard deviation is 1. And what do you know? 50%, 0.5. Now I know there's a little bit of rounding error, but that's probably because I didn't take it all the way to infinity. I just put a bunch of 9s in there. Now we're going to go to 1. Now please note that this is a +1, and matter of fact, this is a +2, and this is a +3. So we're above. So since we're above the middle, at +1, that's more than half. So these should be more than half. All right, so let's draw our picture. This is 0, and I'm just put the 1 there, and we always shade to the bottom. We always shade to negative infinity. So norm CDF, my lower bound is negative infinity. My upper bound, in this case, is +1. My mean is 0, and my standard deviation is 1. And by the way, for the standard normal, it's always going to be 0 and 1. So here we go. Second vars, normal, CDF. Don't know if you can see that. I'm going to try this with a different calculator, see if it shows up a little bit better. I don't know if it will or not. Let's see. Turning on. So second vars, normal, CDF. Yeah, that's a lot better. Negative infinity, see negative 99999. I just filled it up. The upper bound we said was positive 1. My mean is 0. My standard deviation is 1. Now, oops. Well, what do you know? Second vars, normal CDF. Probably gonna give me an error again. Nope, it didn't. 0.8413. I thought maybe I had something turned on in the background. And by the way, a lot of times if you get an error, that means you have something to turn off, either a stat plot or something in y equal. So 84% is below positive 1. So if you are at 1 z-score, you're 84th percentile. 84% of the population scored lower than you. All right, when we go to positive 2, that's right here. And then once again, we're still going to negative infinity. We're still writing down, and by the way, I expect you to write all this down. Norm, CDF, negative infinity. Upper bound, well, where did we shade to? We shaded to positive 2. Mean is still 0, and our standard deviation is 1 because we're working with a the standard normal. So second vars, norm, CDF. Upper bound is positive 2. And we get 0.9772. Now, some of you are probably pointing out, you're going, you know what, Mr. Spencer? You said 95% was between plus or minus 2. And you're right, I did. When this is 97%, so it's not quite that close. Well, why? Well, 95% is between negative 2 and positive 2. But we didn't go between negative 2 and positive 2. We took positive 2 and went all the way to negative infinity. A better way to say is we went from all the way from negative infinity up to here. So we included this part right here when we did this problem. Whereas the empirical rule is only centered on it. So it went 2 standard deviations below and 2 standard deviations above. It did not go to negative infinity. And then we go to positive 3. Well, if you're 3 standard deviations above, you're actually doing really well. And matter of fact, you're fairly rare. So this is negative infinity. Once again, norm, CDF, negative infinity. 3 is my upper part of the shading. 0 is my mean, standard deviation of 1. When we do that, what do we get? Second vars, normal, CDF, upper bound of 3. And we get 0.9986. So 99.86% of the population scored below you if you're 3 standard deviations above the mean. All right, so if you're 3 standard deviations above the mean, you're 99.86% of the population's above you. This is your percentile rank. If you happen to be 2 standard deviations below the mean, your percentile rank would be 2.77. If you're 1 standard deviation below the mean, you're 15.86. So about 15% scored below you. So these are what these are. These are all percentile ranks. They're also probabilities, but they're percentile ranks because we went from negative infinity to positive infinity. And please notice, percentile ranks are not the same as the probabilities given by the probability by the empirical rule. And we can see that because this 3 is not 99.7. This 2 is not 95%. All right. Okay, so continuing with the calculation of z-scores. Actually, I'm going to stop this and make this a separate video.